Alright, howdy. So we'd like to look at this same configuration, only instead of having um, plates just in the same direction as the long direction of the cylinder, right? We'd like an identical set of plates doing exactly the same thing in the perpendicular direction there, right? And that means, since they're identical plates, if this one gives a factor of E and this guy gives a factor of E, right? Then those two things are going to have to add. Now the field is going to add vectorially, right? The electric field has a magnitude and a direction, so it's a vector. Actually, it's a vector at every single point in space. It can differ. But if you have two different sources, you have to add the fields from both sources. That's superposition. And that is going to basically be what we're doing here, right? So how do we add two vectors? Well, basically, if we have two perpendicular vectors, to get the magnitude, we just have to add the squares, right? So e squared is equal to e1 squared plus e2 squared, which is 1 times 10 to the 5th newtons per coulomb in both cases. So 1 times 10 to the 5th newtons per coulomb plus 1 squared plus 1 times 10 to the 5th newtons per coulomb squared. That's just 10 to the 10th newtons squared per coulomb squared plus 10 to the 10th newtons squared per coulomb squared. 10 to the 10th plus 10 to the 10th is 2, so we have 2 times 10 to the 10th n squared over c squared. So then we have to take the square root of that. So it's the square root of 2 times 10 to the 5th newton squared per coulomb squared, which is 1.414 times 10 to the 5th newton squared per coulomb squared. And that's basically all that first question is. Now we need to figure out what the angle is. Well, this is not so hard, right? Now if I give it to you in a problem, they're probably going to be different. So let's just look at what this is. Say we have E1 going up and E2 going down. We'll use our convention from the x-axis up, from the horizontal axis up, as theta, unless otherwise specified. So that means the tangent of theta is equal to E1 over E2, right? So that's right, because our resultant E is this guy here. So these are basically the components of E. So that means that for us, the tangent of theta is equal to 10 to the 5th newtons per coulomb over 10 to the 5th newtons per coulomb, which is 1, which means that theta is equal to 45 degrees. Finally, we want what is the direction of the net force on the cylinder. Here we have to come back. We're asking for the net force, right? Which is going to be which way the cylinder accelerates. Okay, x and z. And then we have our weight coming down. Then we have our force coming up this way. Now remember, this guy was designed to exactly counteract the weight here. What does that mean? That means in the z direction, the z component minus the weight is equal to 0. So actually our magnitude is this way. So our x component is Fx equals ma, z component is 0 means this is horizontal. That means that theta is equal to 0 degrees. Okay, so in this case, we use a little bit of trigonometry there. We used the Pythagorean theorem to add these two perpendicular vectors. To add perpendicular vectors, you use the Pythagorean theorem. To find angles, we often use the tangent, right? You just say, okay, if I know the x and the z component, then I can use the ratio of those, of the z to the x component. This is rise over run. You remember rise over run. After you divide those, you take the arctangent. Type whatever the result is, then press second 10, and that should give you the arctangent, 10 to the minus 1. And that will spit out an answer, 45 degrees. I will ask for the answer in degrees or in radians, whichever I think is most useful on the homework assignments. So make sure that your calculator is in degrees if I ask for degrees, radians if I ask for radians, and you don't have to worry about the other one. There's usually one more that shows up on your calculator. Don't worry about that. It better be in degrees or in radians, whichever one I ask for. If I don't ask for it on a test, to be honest, if I ask for it on a test, as long as you have the right units, if you have the degrees with the degrees or the radians with the radians, I'll be fine. I know what the difference is. Okay? If you mix them, then you're in trouble. But I'm sure you won't mix the radians and the degrees. And finally, we use some reasoning skills based on what we knew from the previous problem to figure out what the net force was. So, sounds pretty good to me. I hope it sounds pretty good to you. We will talk in just a few minutes.